ZBL U5200-5100 ultrasonic detector. ZBL U5200-5100 are digital and portable non-destructive testing instruments which are used to test strengths, defects, cavities of concrete, crack depths of concrete surface, and integrity of pile. U-series of ultrasonic detectors are mainly composed of a host, transducer, and signal wire, etc. You can operate the host through LCD touchscreen and keyboard on the right side. Adjust the gain value through pressing the plus sign and the minus sign, moving the waveform position through pressing left and right keys, adjusting threshold values by pressing up and down button. The ports connecting the transmitting and receiving transducers are on the left side of the host, and ZBL U5100 has one receiving port and one transmitting port. ZBL U5200 has one transmitting port and two receiving ports, so in this case, the channel connecting the planar transducer should be the same as the channel you set in the instrument, or no data can be collected. You should choose two channels when you set the parameters if you use two receiving ports. This is a power switch, and this one is charging indicator. Under protective cover, you can see charging interface to mini USB ports for transferring data files. On the right side is a standard USB port into which the flash disk could be inserted and then select and copy the project's data you need. The instruments and the planar transducers are connected by signal wires. The planar transducers has both the functions of transmitting and receiving ultrasonic signals, so there is no need to distinguish when using. Coupling agent is required between the transducer and the object to be tested and prepared in advance. It is necessary to do zero setting before ultrasonic test. Zero acoustic time refers to the acoustic delay between ultrasonic instruments, transmitting and receiving transducers, and signal wire. Zero setting can be obtained zero acoustic time through testing, and zero acoustic time must be eliminated from acoustic time value tested. Zero setting is required when operating ultrasonic instruments and replacing transducer or signal wire in the first time. Press the zero button in parameter interface and apply coupling agent to the contact surface of a planar transducer. Put the two contact surfaces together. Press zero button. When waveform turns steady, press stop button. An information window with the new zero acoustic time tested pops up. Press OK button, then you finish zero setting operation. Analyze data collected through ultrasonic detection data processing software on computer. Analyze different test data with different analysis software, and different analysis softwares share some common functions. And the following is the detailed introduction for this. Opening and saving data. Click the file on the menu bar and choose the data you need to analyze and open. Save the modified data or save the modified data as a new file. Improve data information. Perfect and modify component information at Component Information area. Click Project icon in the toolbar. You can improve project information there. Data operation. Right-click at waveform area and check left-click to set head width. After finding head width, right-click and choose TNA. You can reset the position of head width. Click Waveform Parameter. A parameter window pops up, and zoom in and zoom out waveform, etc. here. Check waveform movement. You can drag waveform left and right by holding and moving the left mouse key. Click wavetrain icon in the toolbar to switch to wavetrain map. Right-click at the waveform area, a wavetrain display parameters window pops up, and you can adjust amplitude and track pitch, and so on. Part 3. Cross-hole ultrasonic logging for testing pile integrity. Preparation before test. You need to test the pile integrity with U5200-5100 manually, instead of automatically, and tape, guide wheel on pipe mouth, radio transducer are required during the test, so prepare or purchase in advance. If there are a large amount of piles to be tested, you'd better choose to purchase the testing equipment with automatic recording function, as manual operation of detecting pile is inefficient. Name the sounding pipe before the test and measure the clear spacing of the outer wall of sounding pipe. U5200 has one transmitting channel and two receiving channels. U5100 has one transmitting channel and one receiving channel and can test only one profile at one time. On-site test. The pile to be tested has 3 sounding pipes and has 3 profiles to be tested. And this time, we use one transmitting channel and one receiving channel to test the pile integrity. Put a radio transducer into sounding pipe number 1 and number 2, and meanwhile, place guide wheel into sounding pipes. With the help of guide wheel, put the radio transducer into sounding pipe. Check the height mark and make sure the radio transducers at the same height. Connect host and radio transducers and click the detecting integrity of pile. Click parameter, set project name, pile number, pile distance. As for receiving channel, you should select the channel that connects radio transducer. Spacing refers to the distance each time the transducer is lifted. And now, test procedure is demonstrated by taking 10 cm as an example. If not necessary, you don't need to set advanced parameters and press OK button to return to test interface. Press Sample button to start sampling, and if the header wave is not clear, you can click Search button to search header wave. Click on Profile Name to display the waveform on the full screen, and meanwhile, the button for adjusting waveform will appear at the bottom. Use finger to slide up and down on waveform area to adjust the gain of the waveform. Slide left and right to adjust the waveform position. Adjust the threshold value position by click up and down button. Press Save button after the waveform turns steady and input starting height, which refers to the height of transducer, and then click OK button. Lift the transducer by 10 cm and press Save button after the waveform turns steady. The data tested is displayed in the data table area at the lower left and the image display area of the data on the right side. Lift the transducer by 10 cm again and press Save button. Test all points in this way. Pay attention to the changes of the waveform during the test, and adjust it in time to ensure the header wave is on the screen. Press Sample again to stop sampling. Having tested the 122 profile, click Profile, and then choose 123 profile. Relocate the radio transducer in sounding pipe 2 and put it into sounding pipe 3. And do the test in the same manner. Having tested 1, 2, 3 profile, detect 2, 2, 3 profile, and then we finish the rest of this pile, and you can detect other piles. Data analysis. Click Foundation Pile Integrity Testing on computer, and open the files you need to analyze. On the right side of the waveform area is critical values of acoustic parameters. When default is chosen, all values are calculated by computer and cannot be modified. When quote is chosen, some values can be modified. After the parameters are changed, computer will recalculate and take effect. Click Apply to All, set a critical value of acoustic parameters of the remaining profiles to be the same as the current profile. Data list area shows the original test data and intermediate results of the current profile. Click the Abnormality List button in the toolbar to switch to Testing Points Abnormality List of the current profile. The bottom right shows the curve map. Click the corresponding button in the toolbar to switch to Curve of All Sections map, Wavetrain map, and Wavetrain Shadow Graph map. Click Pile Information button to improve pile information. Click File, choose Generate Bitmaps. Select the content of bitmaps, click OK, and save to specified location. Part 4. Ultrasonic Rebound Combined Method for Testing Concrete Strength. Preparation before test. The area to be tested needs to be cleaned, leveled, and dried, avoiding the dense rebar area and embedded parts. It will be perfect to select the area on the side of concrete pouring direction. The measurement area should be evenly distributed, and the distance between two adjacent measurement areas should not be greater than 2 meters. Measurement area size should be 20 cm by 20 cm. Measurement area should be numbered, and you should record their location and appearance quality. Take a diagonal test as an example. 20 cm by 20 cm measurement areas are drawn onto opposite surfaces of the component, and this measurement area onto opposite surfaces must be symmetrically distributed. Distribute 3 ultrasonic testing points on the diagonal of each measurement area. Even arrange 16 rebound testing points on each measurement area, 8 testing points on ultrasonic transmitting side, and 8 testing points on ultrasonic receiving side. The ultrasonic testing points and rebound testing points cannot overlap. On-site test. Do rebound test firstly. Apply coupling agent at each ultrasonic testing point after rebound test. Connect the host and planar transducers with signal wires. After starting up, enter the detecting strength of concrete. Click Parameter and build project name and component name here, fill in test area and ultrasonic testing points number, and we choose 3 here. Test method include opposite test, surface test, and corner test, and we choose opposite test here. Distance refers to the center distance between the planar transducers and merit before the test. Test surface, choose side. Test angle, choose 0. Set design strength based on the actual strength. Click Advanced, choose the channel connecting the planar transducer, and if not necessary, don't choose Modify other parameters. Click OK to return to test interface. Press Receiving and Transmitting planar transducer on the first pair of testing points of the component. Press the Sample button. Adjust the waveform to make sure head wave appear on the screen. Press the Save button after the waveform turns stable. Moving the receiving and transmitting planar transducers to the second pair of testing points, press the Sample button, press the Save button after the waveform turns stable. Test all testing points in this way. Having completed the test, double-click arm form. Rebound data modification window pops up, and fill in the distance and average rebound value based on the test result of digital rebound instrument. Then the presume the minimum FCU. FCU means compressive strength value. The meaning of FCU, the standard deviation of FCU are displayed at the lower right of the screen. Data analysis. Click the concrete strength test software on computer and open the data file you need to analyze. On the right side of the waveform is a single component strength distribution map. Click the corresponding icons in the toolbar to switch to Batch Component Strength Distribution Map and Batch Processing Result. The batch processing map will be valid after a batch processing calculation has been performed. The bottom left shows the original data of each testing point of the current component. Click the corresponding buttons in the toolbar to switch to ultrasonic data or rebound data. Click RM value in ultrasonic data and modify it. Right-click at rebound data area and input rebound values. At the bottom right is the component list, and the corresponding icon in the toolbar can lead to a wavetrain map. Click the PC icon in the toolbar to choose curve types, aggregate types, and other parameters. Part 5. Ultrasonic transmission method for testing uncompacted and cavity. Preparation before test. The area to be tested should be a pair of parallel surfaces, which should be clean and flat, and should cover normal and suspicious areas. What's more, the normal area should be larger than the defective area. Testing points should be no less than 20 pairs. Grid-like testing points are arranged onto relative parallel and opposite testing surfaces, and the spacing between testing points is generally 10 cm to 30 cm. On-site test. Connect planar transducers and host with a signal wire, and click Detecting Defects of Concrete. Click Parameter to set project name, component name, filling row, column, and distance according to the arranged measurement area. Click Advanced, choose the channel connecting the planar transducer. If not necessary, other parameters need not to be modified. Click OK button to return to test interface. Having applied the coupling agent to the component surface, and press planar transducers on the first pair of testing points. Click Sample button, adjust the waveform to make sure head wave appear on the screen, and click Save button to store the first pair of data as the waveform turns stable. The detailed data will be showed in the table at the lower left of the screen, and the detective points measured would be marked in red in the diagram on the right. After finishing the test of the first pair of testing points, moving the receiving and transmitting transducer to the second pair of testing points, adjust the waveform and click Save button to store the data after the waveform gets steady. Detect all testing points in this manner. Data analysis. Click and open Concrete Defect Detection software on computer and open the files you need to analyze. On the right side of the waveform area is critical values. When default is chosen, all values are calculated by computer and cannot be modified. When quote is selected, all critical values of acoustic parameters can be modified. At the bottom left is the data list. displaying the original test data and intermediate results of the current testing points. Switch to the abnormality list by clicking the corresponding button in the toolbar. The bottom right shows component list, and click wavetrain in the toolbar to switch to the wavetrain map of the current component. Right-click on wavetrain map to adjust the amplitude and track pitch and so on. Click Default Sketch Map in the toolbar to switch to Default Sketch Map, displaying the abnormal time and amplitude of the testing points of the current component in a grid. Click PC button in the toolbar to set test method and calculation method of the component. Click the file in the menu bar, choose Generate Bitmaps, select the content and wave spectrum, then you can get the image file of the component. Part 6. Ultrasonic method for testing crack depths. Preparation before test. Test crack depths by ultrasonic method require the crack depth shall be less than 50 cm, and there must be no water or mud in the crack. Non-crack cross data shall be tested firstly, followed by test of crack cross data. The mirroring line should avoid the axis of rebar or forming 45-degree angle with the rebar axis to prevent ultrasonic wave running along the rebar to cause a short circuit. Draw a line in the clean and flat, crack-free area of the component and determine 3 to 6 points on the line. The distance between point 1 and point 2 is 100 mm, and the distance between the other points is 50 mm. Find the widest position on the crack to be tested and draw a line across the crack. 3 to 5 testing points are symmetrically arranged on both sides of the crack. The spacing of the first pair of testing points is 100 mm, and the spacing of the second pair of testing points is 150 mm. The spacing of the third pair of testing points is 200 mm, and so on. On-site test. Connect planar transducers and the host with signal wire. Click Detecting Depth of Crack. Click Parameter to build project name and component name. After new component is created, the first default test is non-crack cross data test. And the crack cross data test cannot be done without non-crack cross data test. Start distance refers to the inner spacing of receiving and transmitting planar transducers, which is 100 mm. Step refers to the relative moving distance between transmitting and receiving transducers, and which is 50 mm. Click Advanced and choose the channel the planar transducer connect. It is suggested to take 0 setting before test, and don't modify other parameters if not necessary. Click OK and return to test interface. First of all, take a non-crack cross data test. Having applied coupling agent to the component surface and press planar transducers on the first 2 testing points. Click Sample button, adjust the waveform to make sure head wave appear on the screen. Press Save button to store the data of first testing point as the waveform turns stable. Check testing date on the data diagram area. Keep the planar transducer at the first testing point still and move the other planar transducer to the third testing point. Adjust the waveform and press Save button as the waveform turns stable. Keep the planar transducer at the first testing point still and move the other planar transducer to all testing points left and do the test. Note: press planar transducers with consistent force. Click Stop to stop sampling. Having done the non-crack cross data test, click New Crack, Input, Crack Name, and Start Testing. Place 2 planar transducers on the first pair of testing points on either side of the crack. Click Sample button, adjust the waveform to make sure head wave appear on the screen. Press the Save button to store data as the waveform turns stable. Move transducers to the second pair of testing points at the same time. Adjust the waveform and press Save button to store data as the waveform turns stable. Move the planar transducers to other symmetrical testing points on both sides of the crack in turn and detect all testing points. Click the Stop button to stop sampling. Having done the test, the instrument will calculate crack depth automatically, and the result will show at test point data list area, crack data list area, and regression curve area. Click when data at crack data list area, test point data list area will show the test result of the data, and the horizontal line represents the crack depth is less than 0. Click New Crack. You can detect another crack of this component. If you need to measure another component, set parameters again. Data analysis. Click the crack detection software on computer and open the data file you need to analyze. Click Apply All button at the crack information area. The information of all the cracks in the current file is all modified to be the same as the current crack. Click Default button. Last saved crack information is defaulted as the information of the current crack. Menu button is valid as the current data is cross-crack data. Regression results area shows the regression analysis results of non-crack cross data. The list of ultrasonic data at the bottom left shows the original data and intermediate results of the current crack testing points. You can modify the test distance and acoustic time. The list of cracks is displayed at the bottom right, and the corresponding icon can be clicked in the toolbar to switch to the wavetrain map. Click File, choose Generate Bitmaps, and display the results in a picture.